Hello guys. Okay, today's concept is speed. I just noticed I am in my 10th semester of my PhD and I just want to finish it and say goodbye to PhD. We need to be fast, guys. Let's go, let's finish this motherfucker today, right today. Finish this PhD! PhD should be finished by the end of the year. By the end of the year, yes, we are going to finish PhD by the end of the year. That's it, that's what I want. Let's go finish PhD. 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 So the paper I want to work with today is coordination via selling information. How can we sell information in order to coordinate people? So, guys, really, I'm tired. Every day we are going to show up here. Honestly, that's it, that's over. For 1.5 years, I'm going to be in my beast mode. I want to work like a horse. Enough. Just fucking publish paper. I want to be a printer, you know? I don't care if my papers matter to anybody or not. I just want to finish my PhD and that's it. So, for finishing my PhD, I have to finish this paper first. Let's finish the PhD. It is the sentence I should say 5 times every day, at least. Morning, noon, afternoon, before noon, evening, midnight, 3 a.m. I will set an alarm, 3 a.m., wake up and say, I have to finish PhD 5 times. That's what I want to do. In the gym, I don't want to listen to music anymore. I just want to record my voice like this. How can I put it on a voice recorder? Where is it? Where is my voice recorder? Finish your fucking PhD. You are a 5th year PhD student. Finish your PhD. Finish your PhD. Finish your PhD. Finish your PhD. So I will listen to this. Alright, rename. Honestly, I'm willing to lose half of these muscles to finish my PhD. Rename, save to files. Nope. Why doesn't it have rename option? Share, edit recording. Alright. No, what do you mean? What the fuck is happening? I cannot rename. Duplicate, move to folder, save to files. Done. I don't know what is wrong with this. Edit. This one. What the fuck? Finish your fucking PhD. You're a 5th year PhD student. Finish your PhD. Finish your PhD. Finish your PhD. Finish your PhD. I don't know how to rename it, but that's what I will play in the gym. Finish your PhD. Finish your fucking PhD, motherfuckers. So, finish your PhD, Garshan. Finish your PhD. Let's see what's up. Finish your PhD. R positive is done. We did it last time. We did. Finish your PhD. Finish your PhD. This is a torture. This is a torture. Finish my PhD. I hate PhD. Finish my PhD. I hate finishing No, I love finishing PhD. I hate staying a PhD student. Alright. Overleaf. Finish this shit. Finish. Finish! PhD. Alright. What is the next step? We did our outside 1 minus 1 is 1. 1 over n minus 1. I don't know. What is the next step? What is the next step? Okay, guys. Let's give ourselves some time to finish our PhD. These are bullshit. Let's keep them. Okay, next steps are welfare. Proof of proposition. This sigma omega is greater than sigma r. Greater than sigma n. And what else? For my benchmark, comparing mu's are enough. Okay, we did this part. Let's just discussion on insights, implementation plots, proof of proposition. I think this is the most important one. Let's go let's go add some momentum to this part of the project. Which proposition, by the way? I don't know which proposition. Let's fucking finish. It's about a comparison. Proposition 5.4 for r in minus 1 over 1 over n minus 1. Coefficient in the welfare and satisfy this. Alright, there is no proof for it now. Let's see which one has a proof. Overleaf. Let's start from the first one. Optimal mechanism. Optimal mechanism. Well, this one has a proof. No. Proposition 4.4. The welfare optimal mechanism of proposition satisfies this. Okay, it has a proof. And that's a fucking good proof. 4.5. So we want this one actually. We want to, because it has half of the comparison. However, it's just welfare. It's no revenue. In 5.4, we want to compare welfare, revenue, and Nash equilibrium. So, and I feel comparing welfare and revenue is more important. But I want to keep this. I want to keep this. So let me open a new one here. Okay, this can be here. Proposition 4.5. There is no comparison here. 4.6. Nope. 5.1. Proof is already there. 5.3. It's all good. The proof in proposition follows closely one over and is provided in Appendix B. Let's see if they have it. Mm-hmm. 5.3. Yeah. So the remaining one is proposition 5.4. And what is the proposition? For R in -1 n 1 over n minus 1, the covariance coefficients in the welfare and revenue maximizing mechanism satisfy sigma ai omega, sigma ai r, sigma ai, oh, alright, sigma ai, that's the comparison. For the proof, I don't know what's the point of proving these bullshits. As we see, the seller is able to coordinate the players' strategies and generate increased welfare compared to these are good. You should bring insight, full information, Nash equilibrium by making the action recommendation more reactive to the players' private types and less reactive to the state. In the revenue optimal mechanism, the seller still distorts the complete information action recommendation mechanisms. This is not good. When you have a sentence like that, it shows that you are doing bullshit. You are doing mental masturbation. The seller still distorts the complete information, action, recommendation in the same direction but less intensely, thereby reducing the player's information, rentation, remarcation. Fuck this shit. I cannot understand this problem. Remark when R. Okay, we added the remark. Let's prove. So here we have the proof of proposition 4.4 for comparison. R between -1 and 0. What about when R is -1, 0 and 1 over n minus 1? Alright, let's look at the proof for the previous one. sigma AI omega of lambda, sigma AI theta I of lambda. The functions of lambda in 17. What is 17? Finish, PhD, finish, PhD. Guys, don't forget. Finish your PhD, 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 finish your PhD. Alright guys, we want to finish my PhD. Finish PhD. Finish your PhD. Alright. For R minus 1, 1 over N is minus 1. The covariance coefficient in the welfare and revenue maximizing mechanism satisfy this. Fuck you. 17. Where is 17? Ah, okay. So 17 gives us sigma I omega in based on the proposition. 4.3 gives us sigma I omega, sigma I theta I based on sigma I omega squared, sigma theta I squared, but for sigma I theta I it's an ugly equation. By the way, I don't know how we are going to prove it for proposition. What about R outside? So, okay. When R is positive and less than 1 over N minus 1, hopefully, I haven't checked, the equations for sigma I theta I and sigma I omega are the same as equation for sigma, the same parameters when R is negative. We have it in proposition 4.5, and that may help us. Yeah. So you have proposition 4.8, which we don't have a proof for. Sigma AI omega W is less than N, exactly. Theta I W is greater than N, and AI theta J W is greater than N. So I feel proposition 4.8 must have a similar proof as proposition 4.4, and probably we can practice by proving that for proposition 4.8, and then we have a better understanding for the 3-parameter comparison. 5.4. All right. So let's see how we proved it. Using the notation, we can write the Nash equilibrium as this, which was difficult to be honest. We denote by sigma AI omega of lambda and sigma AI theta I of lambda. Okay. So sigma AI theta I and sigma AI omega are on a curve. The functions of lambda. Lambda is the solution to the degree 5 equation, I guess. or 3? Mm, lambda is an equation, degree 4. The unique positive root of this equation. Degree 2 in the denominator on the left hand side, and it's a degree 4 equation. Alright. We denote by sigma ai omega. Function of lambda, these functions interpolate in 17. What is 17? Okay. We just checked 17, there was no lambda there. Oh, there is lambda. So 17 gives us the equation for sigma I theta I sigma I omega based on lambda, but at the sigma ai omega for the Nash equilibrium doesn't depend on lambda, which makes sense. So it says Nash is these functions interpolate continuously and monotonously between their value at 0 and their value at infinite, which is the center of the ellipse. So we have these curves, and we have this ellipse which comes from our constraints. We have these curves with sigma ai omega and sigma ai theta I are on it, and these curves at the infinite hits the center of ellipse, and at 0 it is the value, I think at 0 it doesn't hit the ellipse. Alright, let's see. We have sigma ai omega of 0 this, sigma ai omega of infinite is this, 0 is this, infinite is this. From these expressions, it is easy to verify the following inequalities when r is in the interval -1 and 0. I feel we also have a plot for it. So we have is it center and finish your PhD, 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 finish. I want to finish my PhD, finish my PhD, finish my PhD, finish my PhD, finish my PhD. I want to write a paper, 2 paper. Okay, that's here. Figure 1, representation of mechanism in the sigma ai omega, sigma ai theta I plane. Plane with r negative and t negative. It's better to change the order of this. when action recommendations are maximally correlated condition on theta and omega. An obedient mechanism is uniquely determined by a pair of sigma I omega, sigma I theta I lying inside an So, obedient mechanism is uniquely determined by a pair of sigma I omega, sigma I theta I, where lying inside an elliptic region epsilon, whose boundary epsilon correspond to mechanisms that are deterministic, condition, and theta and omega. Ah, I see. So on the boundary determines deterministic. If you're inside the ellipse, you add randomness. Alright. An obedient mechanism is uniquely determined by a pair sigma I omega, sigma I theta I, lying inside an ellipse region epsilon, whose boundary epsilon corresponds to mechanisms that are deterministic, conditioned on theta and omega. Alright. Stationarity constraints. What are the stationarity constraints? When we make the Lagrangians and take derivative based on the parameters, the welfare optimal mechanism to be a point p lambda. So that is the curve p lambda, which here is p0, right, outside. P of 0 starts from outside, and P of infinite is the center of the ellipse on a portion of hyperbola in green parameter, parameterized by the non-negative multiplier lambda. And lambda is positive, non-negative. Complementary slackness implies that the welfare optimal mechanism is either at P0. When is it at P0? It is at P0 if P0 is inside or on the ellipse boundary, right? If it is outside, it is not obedient, it doesn't work. If it is inside, it means in the interior part, it means we must add randomness. If it is on the boundary, we want it on the boundary, right? Complementary slackness implies that the welfare optimal mechanism is either at P0 if P0 is on epsilon, interior solution, or at the intersection of the hyperbola with epsilon, otherwise boundary solution. The point label N, okay, now, so why did I draw it like that? N is the base Nash equilibrium. That is the Nash equilibrium of the complete information game for each realization of theta and omega. Alright, so we have, I need to move some stuff here. I can edit. p lambda p max 0. Why do we have separate for r negative and r positive? The reason is that for r negative it is always deterministic. For r positive, if I remember correctly, it can be positive. It can be deterministic or random. Alright. This is P infinite. The center. Deterministic. Yeah, deterministic is the boundary of the ellipse because what is this boundary? We have obedience, so our inequalities reduces to two inequalities, and those inequalities come from positive semi-definite constraint for the Gaussian mechanism. So once we are, and they form an ellipse, once we are on the boundary of those, it means that the constraints are binding, and when it is binding, it means like the PSD constraint is binding. It means that our Gaussian is a what is the word? Our Gaussian distribution is like the two of our main variables are dependent of the three others. But when the PSD is not binding, it means that we have 5 variables, none of them is completely a function of the other random variables. So so we are on the boundary. When we are on the boundary of the ellipse, we are deterministic. When we are inside, we have more randomness. And now we have the Nash equilibrium of the complete information gain on the boundary of the ellipse. Alright, I have to go to the restroom to have more information and that. But as long as I'm there and until I come back, repeat with me. We are going to finish this PhD. Finish your PhD. Finish your PhD, guys. Let's kill this fucking PhD. Finish your PhD. If you are a PhD student, you finish your PhD. Do you understand or no? Alright. Alright. P0, P infinity. I don't care about the proof. I just want to finish my PhD. These are all bullshit and I am writing them down, but I don't care because I want to finish my PhD. Don't fall down. Alright. When action recommendations are maximally correlated, condition on theta and omega, an obedient mechanism is uniquely instead an ellipse with boundary epsilon response to mechanisms that are deterministic conditions. Stationarity constraints the welfare optimal mechanism to be a point p lambda on a portion of hyperbola in green parameterized by the non-negative multiplier lambda. Complementary slackness implies that the welfare optimal mechanism is either P at P0 if P0 is on epsilon interior solution or at the intersection of the hyperbola with epsilon otherwise boundary solution. The point labeled N is the mechanism that recommends a Nash equilibrium of the complete information gain for each realization of theta omega. Stationarity further implies that at the optimum point sigma A theta I sigma A lies on a portion of hyperbola parameters ellipse constraint this H where sigma A are functions described in 17, or that when lambda goes to infinity the corresponding point this and over the center of the ellipse two cases described. Either at lambda 0 the point P0 lies within interior solution. All right. What about sigma A theta J? Oh my goodness. All right. When R is negative, you still can have randomized solution. So when R is positive, we always have deterministic solution. Sigma AI omega, sigma AI theta I. No. What about sigma? Alright, I don't get it, to be honest. Too many variables. There is no point. There is no point in these proofs. You know what? There is only one thing good about it. First of all, if we can come up with good insights and interpretation for the results we have. And the second one is that we can write this paper and other people look at it and say, all right, this modeling gives us, okay, they did it, that's nice, but maybe we don't need to make stuff more complicated. Yeah, it gives other people that, okay, that's enough, we don't want to go deeper than it. And now it's the time, like, I think this paper hits the maximum of mental masturbation. And when other people see the peak of the mental masturbation, they say, already we theorize too much. Now, if we want to do something, let's go mental masturbate on another mountain, or let's take some actions. Actually, it is for me too, right? My experience came from that. Okay, I did a lot of theory work. There is nobody interested in implementing these ideas. So maybe now it's the time for some more practical, experimental research. If I didn't do this kind of work, I would never know that, okay, I don't like too much theoretical work in an applied field. So I should not be sad. Let's just finish this. It doesn't take us much time, and then we know what we want to do now. If we didn't do this project, we wouldn't know. And if we didn't apply for internship and everything else, we wouldn't know if it is what we want or we don't want. Now that I have this feeling that I don't want because I'm here, I went through this path. Using the notation f1 over n minus 1, we can write the Nash equilibrium as this. Oh my god, we need to note by sigma a omega lambda, sigma a theta I lambda, the function of lambda in 17. These functions interpolate continuously. From these expressions, okay, it is the proof that it is comparing the Nash equilibrium and the complete information Nash and the optimal welfare. From these expressions, it is easy to verify the following inequalities when R is negative. How is that easy? Okay, it's just a basic high school math, it seems. N is between infinite and 0, omega. Alright. Sigma I omega n. This is the so first case, sigma ai omega 0, okay, here outside is less than n, something here, alright. In this case, either we have an interior solution, but then sigma ai omega W, welfare. By assumption of this case in sigma A theta. Sigma A, where is 0? 0, I don't know if it is positive or negative. We have a boundary solution. Sigma AI theta AF lambda in, why is that greater than n, absolute value, sigma AI 0. So it is positive. Assume it is positive. Is this proof complete? This condition is equivalent to 0. So then it compares the lambda for which sigma I omega of lambda n equals to sigma I omega of n. Lambda is 16 is violated. What is 16? The inequality. Oh. Implying that lies outside the ellipse. Okay, guys, I didn't even get the proof for just comparing. I know that, yeah, they are comparing the curve when it cuts the ellipse, and I can try to prove it for myself, then add revenue to it. Then I can add revenue to it, and I understand the rest. Like, what about R positive? We don't have proof for that. Then we can prove it for R positive, and then we can prove it when there is revenue, welfare, and complete information Nash equilibrium. When we have all three of them. So that's, I think, a good idea. Yeah, I need to do the proof again. To-do list, checking up tomorrow. I feel after that we have to yeah, that's it. That's what I want to do. I want to prove proposition 4.8, 4.3, 4.4. Prove proposition 4.4 for myself again. And then check it with Thibaut's proof, and then go right down the other part. Alright guys, we got back to the work again. Good news. And we know what we want to do next. It's all good. Thanks for being with me. Still we are lost in the project, but I feel the rest of the project are some small steps. We don't even know if they are necessary or not. The main part is done, so I want to shift my focus on my thesis now, and I will start doing it. Thanks a lot, and oh, I should go there. Goodbye.